Okay, let's move on. Still dealing with polynomial functions. Now we're going to use the graph of a polynomial function to find the solutions to when the function equals 0 and to find the factorization of the polynomial. So here we have a polynomial function. It's a 4th degree polynomial. It's got 5 terms in it. It would be a mess to try to factor. So instead of trying to factor this to find the factorization, we're going to look at the graph to find the factors. So we're going to look at the graph. They give us the graph here. And we see that the graph crosses the x-axis 3 times. We know that anywhere it crosses or touches the x-axis is an x-intercept. So we have an x-intercept of -1, we have an x-intercept of +1, and we have an x-intercept of 7. Now, when you have an x-intercept that only bumps the x-axis but doesn't go all the way through it, like this one here at x equals -1, then we say that that's a double root. So that root actually happens twice. That solution actually happens twice. So we have our solutions here. We can count x equal -1 and we can count another x equal -1. And then we would write our equation. Well, our equation is going to have a factor for each of these solutions. And it's going to also have the same a leading coefficient as our polynomial. So the leading coefficient here is -1. So I would list that first. Then for my x equal -1, I would have the factor of x plus 1. And because that touches the x-axis but doesn't cross it, I have x plus 1 to the 2nd power. That's what I mean by it occurring twice. In the factorization, it's going to be raised to the 2nd power. Then the x plus 1 gives me a factor of -1, and the x equals 7 gives me a factor of x minus 7. I think I said that backwards. The x equal 1 gives me a factor of x minus 1, and the x equals 7 gives me a factor of x minus 7. So the complete factorization is negative, or -1, if you want to put the 1 there, you can, times x plus 1 squared times x minus 1 times x minus 7.